Hello everyone, welcome to this session number 10 on basic spatial analysis as part of the online training program on introduction to remote sensing and GIS using QGIS. In the previous sessions, you have seen how to work with vector data and raster data in QGIS and also how to make use of georeferenced raster data for creation of vector layers. In this session, you will see how to make use of delimited text or tabular data and how to create GIS layers, GIS vector layers from such data sets. You will also see some basic spatial analysis covering vector and raster data sets. Let us look at working with tabular data. For using tabular data in QGIS or any other GIS application, it should have spatial data component in it. That is, locational information should be contained. Otherwise, we cannot translate the data into any spatial layer, and the data needs to be structured. It cannot be in an unstructured manner. For example, it has for a delimited text file, an Excel sheet or a spreadsheet is an example. A delimited text file is something is like an attribute table that we have seen in case of vector layers, with each column or field separated by a defined character and each row or record separated by a line break. The first row usually contains the column or field names. A common type of delimited text file that we come across is CSV file, which is a comma separated values file where each column is separated by a comma. Similarly, we can have other delimited text files, tab separated values TSV file, colon separated, semicolon separated values file, etc. So this is one example of a tab separated file which we can use it in QGIS for creating a vector layer. Suppose you have the data along with spatial component, that is location, latitude and longitude information in the form of a Excel sheet or the spreadsheet. It is well and good. You can make use of it directly uh, to in the import it into QGIS and create a vector layer. In case if you are having tabular data in a PDF file, then also you can try to create. For example, this National Register of Large Dams is a publication which lists the specified large dams state-wise, and the information contained includes latitude and longitude information as well as other attributes. You can say you can create a delimited text file by using the information contained here. I had done the same using the previous publication of National Register of Large Dams, and I had created a Excel spreadsheet of large dams of Karnataka, and then I saved it as a text file, which is basically a tab separated value file. Now suppose if you have the same thing has been provided to you in exercise data. Suppose you have this text document which is a structured delimited text information. Then let us see how you can import it into QGIS and create a vector layer. So you can launch your QGIS and then go to data source manager as the or you can go to layer and click on add layer and select add delimited text layer. In either case, it will open the same dialog box. You select the tab of delimited text and then you browse the file where you have saved it. It is on, I have saved it here in the exercise data session 10 Karnataka underscore dams underscore NRLD. Now try to keep, don't keep any namespaces in your files or in the folder paths. to avoid any issue. So I have, as you can see, I have kept a underscore to separate the words. So this is not a CSV file. As you can see in the interface, it doesn't the column headers are coming together instead of coming in the form of a column. So you can check the custom delimiters. It is a tab separated value actually. So you can select the tab. So then you will see that your delimited text file is a tab separated file, which is just in where the data is in a structured manner with all the column headers, first row containing the column headers. So you can use it, and also it has locational information in the form of latitude and longitude. Therefore you can use it for creating vector data. Then once you selected the file format, you can go to geometry of definition, and here you have to specify what is your x field and y field. As in the x direction, longitude varies. You can give the column header where you have the longitude information, which is the longitude. You could it could be anything, the way it has been saved. And then in the y field you select the latitude. Then the geometry CRS, you can because we are dealing with the global coordinates, you can select EPSG 4326. You click this button. It is already here, project CRS, but still you can click this button. That will open a select CRS dialog box. You can search for the EPSG code WGS 84 EPSG 4326, which is a global coordinate system. You can select this, and you can check the layer settings, the sample data under the layer settings. It appears to be okay. Now you can click on add. Then you will find that a layer has been added with the same name of the file, Karnataka underscore dams underscore NRLD, and you can see it has been added as a point coordinates. You can right click on this layer and then click on export and save features as. You choose the format where you in which you want to save your vector layer. You can choose the SRE shapefile that you have been using and give the file name, the same file name, say, and then you can save it in your desktop in your solution folder. I am saving it as Karnataka underscore large underscore dams, and check the CRS, which is EPSG 4326 WGS 84, and keep the rest of the options as they are, and then click OK. Then it will create a vector point data layer. You can remove the old layer that you have added using the tabular data. And now you have created a point vector layer using the delimited text. You can check the folder where you have saved it. You will find that a shapefile along with its associated files has been created. You can see the number of features. You can right click and check this option, show feature count. Then it will show you the number of records in that layer, 231. This will be the number of rows in your original text file. If you do it again, if you click it again, if you uncheck it, it will stop showing the number of features. Now you can open the attribute table as you have been doing by right clicking and then selecting the open attribute table. You can also open the attribute table from the attribute toolbars. Now these are the various toolbars under the main menu. This is the project toolbar, and then map navigation toolbar, and here you have selection toolbar and attributes toolbar. You can add any toolbar and customize your or remove any toolbar in your interface by going to view toolbars, and you can check what toolbars are needed, where you are mostly using. By default, these are the various toolbars which will be visible when we install QGIS for the first time. So here you will find under attributes toolbar, you will find this open attribute table option. While selecting the layer, you can click on open attribute table toolbar button, and then it will open the attribute table like we have seen in the case of vector data. Now it is also a vector data. You can see the attribute table along with the latitude and longitude fields. There are many fields which are the attributes. The river basin, nearest city, seismic zone, where it lies, dam type, height of the dam length, etc. Now let us uh, see how we can work with attributes and then filter the records. Attributes contain information about the objects or features shown on the map, and they are very useful in carrying out spatial analysis. Suppose you are aware of the locality of a dam, or you know about a major dam among these 231 features, and if you want to see its location in the map canvas area, and also other related information, other attribute information of the dam. How to do it? One way is by labeling it, by labeling all the dams. You can do it by this shortcut, right click and show labels. So by default it is showing the name as a label. But then because there are many features here, it is very congested. It will be difficult for you to locate your dam, and also by default overlapping labels will not be shown in QGIS. So not all features are labeled here. So another way is you can let me switch off the show labels. Another way is you can add the base map that we have seen by using this web quick map services, and then if you are aware of the locality, you zoom to that locality and see where the dam is located and see its features in the attribute table. Otherwise you can simply go to attribute table by right clicking and open attribute table, right, and then you can search for the dam that you want to you can just like any Excel sheet, you can sort any of the fields here. I will sort by the name of the dam, and I can look for, like, if I am looking for Almaty Dam, which is a major dam, if I select it here, the same dam will also be selected in the map canvas area, and by default it will be selected, all selected features will be in yellow in color. By chance I am able to locate it here, but it may not be, it is not may not be always be visible because there are so many features, right, in the so what you can do is here let us first check its attribute table, its features, its attributes. So these are the various attributes of Almaty Dam that you wanted to look. It is a composite dam. The nearest city is Basava, then Basava Begawadi, and then the river name is Krishna. Year of completion is 2000, latitude and longitude, and then other information like height of the dam, dam length, etc. All the information you can have a look right. And then suppose you want to select multiple dams, then you can also do that using the attribute table. Right click the attribute table, open it, and then zoom to the sorry, you can press the control button to select more than one dam at a time. So I have already selected Almaty Dam. Suppose I want to also select other major dams like Krishnaraj Sagar and Tungabhadra. You can go to you can sort it and then select. This is Tungabhadra, and then Krishnaraj Sagar, Kabini. So I have selected four dams. Now you can see that all these dams have been selected. You can check their features using Identify Tools tab by clicking on any dam. Then you can deselect the selected features using this option of deselect features from all layers. Uh, because there are many features, you can zoom to the location of any particular dam by if you select the dam, you can right click and go to zoom to feature. This feature will be useful for you to zoom to any particular dam. Suppose you want to run queries for selecting features by attributes. For that, you have many options in QGIS. Let us zoom to layer and deselect all the selected dams using this button. This you can scroll your mouse on onto any button, then it will tell you what it does. It will deselect from all the layers. Now to find all the map features that meet a certain criteria, we can run queries using these options. You can select features by expression. You can select features by value. You can select features by expression. Or you can select features by drawing a polygon by freehand and radius. Now we will explore these two options, selecting features by expression and selecting features by value. Now suppose I want to have a list of all large dams in Karnataka which are at least 50 years old, because we have seen that in the attribute table there is one field of year of completion. So I can make use of that information. So let me select by attribute. Now you go to the year of completion. The field is name of the field is year of CO completion. Then you can select less than or equal to, and then put input 1974. Then therefore all those dams whose year of completion is less than or equal to 1974, that is all the dams older than 50 years, will be selected. And now you can click on select features, and you can see it hasn't selected. Yeah, now all the features which are older than 50 years have been selected. How many features have been selected, we can check it. You can go to the attribute table. Now these attribute table and map canvas area is always linked, so therefore all the records which are highlighted in blue are the selected features. Now you can check this option of in the bottom here. It is now showing all the show all features. You can select this option of show only selected features. Then you can see only those selected features, all the dams which are more than 30 years old. And you can see how many have been selected. 98 dams have been out of 231 dams are older than 50 are older than 50 years. Um, you can also do the same thing by moving the selection to the top. Like if you show again all features, you can select this option button of move to the top, and all those dams which are selected are on the top. Serial number 1 to 98 are the dams which meet your criteria, and remaining they are also there. So now I can save my selected features as a separate layer by going to the layers panel and then right click, then select export, save features as, then this dialog box will open. Now you can save it in the format of S3 shapefile and you can give the file name, say Karnataka old dams in the solution folder, and CRS will remain the same, EPSG 4326. And if you now run this, but be careful, you have to select this, you have to select save only the selected features, otherwise it will save all the 231 features, it will be of no use to you. So select this, save only selected features, and then press OK. Then you will have all the old dams, which is a subset of the 231 dams older than 50 years. You can check its attribute table by right clicking and opening the attribute table. It has 98 features. You can see the year of completion column. The oldest dam is dating back to 1000 AD. It is a tank. And then there are few dams from 19th century and 20th century, and all the dams up to 1974 are selected. Now let us now I will remove this layer. I will get back to the old the Karnataka large dams layer, and let me deselect all the dams. Now if I want to select features by expression, you can check this option in the selection toolbar. You will find one option of select features by expression. You can select it, and now go to the fields and values. You will find all the fields. Suppose you want to select those dams which are located in in a particular river basin, or let us say we want to create a layer of large dams located on the west flowing rivers. So there are two basins, two composite basins, west flowing rivers from Tapi to Tadri and from Tadri to Kanyakumari. There are only two composite basins which comprise of west flowing rivers. So you can check the river basins field, then click on this all unique button. It will list out all the river unique values under the field river basin. So these are the various basins. Then you have to select the dams which are falling in these two basins. So how to do that? You can double click river basin, and here you will have to write the expression that river basin is equal to the unique value number 1, west flowing rivers from Tadri to Kanyakumari, or for or you will use the plus symbol. Let us put the first expression in parenthesis, and then the second expression also you can start. Again, river basin is equal to west flowing rivers from Tapi to Tadri, and then close the parenthesis. Now if there is any error in your expression, you will find it here, expression is invalid at this here, preview. Otherwise if you are careful enough, it will show you the value. So for any value, any of the 231 dams, it will tell you the, it will give you the value. So your expression will result in either it is a Boolean expression. It will give you, if it meets, any dam meets this criteria, it will be, the value will be 1, otherwise the value will be 0. So let me go to select features option. After writing the expression, valid expression, you select it, and now close. And now you can see all the west flowing dams on west flowing rivers are selected. Now you can again right click on the Karnataka large dams layer, and then right click, export, save as. Then you can save it on to your disk. Karnataka dams, west flowing rivers, with the same CRS can run. Now a new layer has been created and it is added to the map canvas area. See, I forgot to select the option of select save only selected features. Therefore, it has it has included all the features. So let me correct it. So export save features as, let me give the same name. I will replace, and then you have to check this box, save only selected features, and then now press OK. Overwrite the file. Export to vector file failed, some issue. uh, Anyway, it doesn't matter, we can save it as a different, with a different file name. I will name it as Karnataka West West flowing river dams. You can give any name, and then select this save only selected features, and then press OK. And now you can see a new layer has been added. I will remove the older one. I will deactivate the original layer. Now you can see this is the new layer which has been vector layer, and you can check its attribute table. There are 26 features, and you can check the river basin column field. So in this way you can select features by running the queries by using the attribute table. Now suppose you want to select by location. Let me remove this layer. Again, I will have the original layer. I will deselect all the features by with this button of deselect features from all layers. Now let we can add the base map and see, as we said. Now let us make use of administrative boundary database shapefiles that we have downloaded from Survey of India online maps portal. So I have it. It is my vector layer. So I will go to the data source manager and then select vector option tab, and then you browse to your location where your exercise data is located. It is a zipped file. Just a minute. So my exercise folder, no, yeah, sorry. So this is session number 9, session number 10. Yeah. So here I have my administrative boundary database. So now let me add, I will close all these windows which is creating confusion, the attribute tables which I had opened. Now let us go to the browser, select by going to the folder exercise data session 10, and then administrative boundary database, and here you can add district boundary as well as uh, state boundary, and then add. Okay, now you place the point layer on the top, and then district layer boundary below it, and then state boundary at the bottom. Now I will uncheck my state boundary. You can see all the my dams are located within the Karnataka state boundary. You can check the CRS of these state boundary and district boundary by right clicking and then properties, by going to information. This is Lambert conical conformal conic projection with the datum WGS 1984. So it is a projected coordinate system, and it doesn't have any specific EPSG code. Uh, Now, in case if you remember, when you were working with the Jurala project layers where you digitized canal network, there the EPSG code was 7756. Right. Um, uh, let us let me show you one website where you will find the information about these projected coordinate systems. efpsg.io, this is one website, and another website is spatialreference.org. So if you select if you search for all the Indian projected coordinate, like let me search by India. So you see all the coordinate projected coordinate reference systems which are pertaining to India. They are listed out. These are all the old projection system: Everest, Kalyanpur. Then the datum itself was not WGS 1984. So you can go. These are all deprecated. We are not no longer using it. Yeah. You see, for every state you will find this EPSG 7765. We were working on EPSG 7756. The project was in Telangana state. Now let me look for that. Yeah, for Karnataka it is 7780. For or you can simply search by the code, which is 7756. Yeah. So this is EPSG 7756. That was the projection system of the files, coordinate reference system of those Jurala files. It pertains to Andhra Pradesh. The datum is universal datum WGS 1984, and then it is actually the datum. It is recommended projected system as per the Natural Resources Management System Secretariat ISRO. So for each state, this is a LCC projection, a Lambert conical projection. For each state, they have this EPSG code. You can have a look at all these states where you have EPSG 7770, Rajasthan 7774, Karnataka. In our case, we can use this EPSG 7780. So these are all LCC projections. However, there is no one single code for the entire uh, country, so you don't have any code here EPSG. So this is better suited because India is not actually a tropical country or a temperate country. Those localities which are near the equator, you can go for cylindrical projection for minimum distortion, whereas in case of India you can go for LCC, and if you go to polar regions, there the azimuthal projection will be more suitable for minimal distortion. So anyway, let us come back. Now let us select features. All the now you can save the by selecting the state boundary. You can select the features by select features by area. You can click inside Karnataka. Now you can simply export save features as to generate a new shape file of Karnataka. That you can do the same thing Once you do it, you let us look at the districts. Suppose I want to have um, list of dams located within a particular district. I want to select the dams by location, say Mandya district. First I have to select I have to prepare a shapefile of Karnataka districts. How do I do it? You can simply make use of select by location, select by at value. Here you can set it equal to, and then how Karnataka is defined in the attribute table, you have to look at it because it is case sensitive. Or if you want to if you don't check this case sensitive, I think you can even type it. Yeah, it is actually, it is showing up. There is some mistake in the way the attributes are listed in the Survey of India shapefile. Doesn't matter, you can select it, and then you can so all the districts, you have selected the district shapefile, and where the state the attribute state is equal to Karnataka, you can click on this select features. Then it will select only the districts of Karnataka state, and then now you can right click and then export save features as. Select the option save only selected features. Never forget this option, and then you save it. Karnataka districts, I have given the name SOI, Survey of India. You can simply save it as Karnataka districts, and then you click OK. Then a new layer will be generated. You can remove the original layers by selecting both of them, and you can remove them. Now suppose let me use this identify features. I will select this district, which is Mandya district. So suppose I want to have the dams located in Mandya district. That is, I want to select the dams by location, select the features by location which are located within Mandya. So you go to this option, deselect everything. You go to this option of select by location, and then you want to select features from Karnataka large dams which intersect or which are within. You can select which are within first, but then you have to have the shapefile of Mandya district itself. So you can select Mandya district, and then you can right click, export save feature as, and then you can save it as Mandya district shapefile, keeping the same original projection of LCC WGS 84, and then click OK. No, I should select only the selected features. Save features as, right click, export save features as, give the name, and then check this save only selected features. Often we leave out this important aspect, and then you click OK, and then you remove the original layer to avoid confusion. So we have this Mandya district, and we have this large dams file layer. Now you go for you select the Karnataka large dams. You go to this select features by location. We want to select features from this layer which are within this layer, Mandya district layer, and you run it. Now once it is completed, you will find few dams have been selected, you can check in the attribute table. You can select the option of show selected features only. So there are only 3 dams which are located within the Manja district. So now you can save the shapefile of these 3 dams as by exporting as save features as, and you can give Manja district dams. Right. Manja dams. Save only selected features and then click OK. Now you can see this new layer has only 3 records of 3 dams. So in this way we can make use of attributes for selecting the features. You can do many things. You can edit the attribute table. Let us do the editing part of attribute table. Suppose when you made the selection, open the attribute table, you know these 3 dams have been selected which are within Manja. Now if you click this option of move selection onto the top, so these are the 3. Now suppose you don't have any field or column of district here, so you want to add a new column or field, then you have to go into editing mode. So you can edit a field or attribute any attribute data anytime by going into this toggle editing mode, this pencil symbol. You can click on this, and once you are in editing mode, you can see these options of new field, delete field, organize columns, etc. Now let me check this new field. Now if you want to add a new field, you can give it the name district, and the type of the data that you are going to save is a text string, and the length, it can be up to 10, and then press OK. Now you will find a new column added at the end with null values. So you can double click and then start typing Mandya in these 3 columns. And if you want to save this attribute table, you have to come out of toggle editing mode. Then it will ask you, do you want to save the changes to the layer? And then you can save or disregard. I am not saving them now. So in this way you can even edit the attribute table. You can even join the tables. You can do lot of things just by making use of attribute table. So you can keep all the layers, you can add all the layers that you have generated, and then you can save your project in the solution folder as some day 3 solution, as something like Karnataka large dams, right? You can save it. And now let us open a new project. As you have observed, there are multiple ways of doing the same thing. From the same things from the menu, from the processing toolbox. There are hundreds and thousands of algorithms in the processing toolbox, which you can explore yourself. Now we will do a simple basic spatial analysis using the vector data created by ourselves. We can prepare a vector data. As we have seen, we can digitize and prepare the vector data. That is one way, but we will not digitize to prepare data, but we will make use of crowdsourced vector data, that is OpenStreetMaps. Without downloading it, we will make use of a plugin, OSM quick OSM plugin. Now as you know, for downloading any plugin, you can go to this plugin option, plugins, manage, and install plugins. Now you can search here for OSM, quick OSM. You can select this. So quick OSM downloads OSM data using an overpass API. This is a API, application programming interface, which will fetch data from the OSM, and then you can add um, it executes custom overpass queries in QGIS to get the OSM data. This has so many downloads, and this is the rating. So let me install this plugin. Be aware that while installing the plugin, you need to be connected to internet, because it is fetching the data from the repository. Otherwise, while working on QGIS, you don't require connectivity. So let me, after installation, quick OSM has been installed. You can check it by going to the vector menu, and you will find a new option of quick OSM has been included. And so you can click this quick OSM, which will open a new it is asking it is open it has opened a new dialog box which says OpenStreetMap is open data, licensed under Open Data Commons database license by this OpenStreetMap Foundation. It requires that you use credit on any product using OSM data. You should read this. So you can select this option of I understand the copyrights and access the plugin. So this is the plugin window. Now what we will do is we will fetch data from OSM, and we will prepare vector data for our area of interest, and then we will make use of that data for doing some small analysis. I am following the QGIS training manual. They have done the exercise for some region in South Africa. I will be doing the same exercise. I will try to do the same exercise for Pune region. Now let us look at it. Now suppose you want to answer the this question. You are a real estate agent and you are looking for a residential property in Pune metropolitan region for clients who have this following criteria. Some criteria for which you have to do the vector analysis, and for some criteria you have to make use of raster datasets and do the raster analysis. So first of all, the residential the property should be located within the Pune metropolitan area that we have defined. We will define the extent of the area, and it must be within a reasonable driving distance of school, say less than 1 kilometer. It must be more than 100 meters in square meters in size, the area of the building, and it must be closer than 50 meters to a main road, and closer than 500 meters to a restaurant, and it is south facing, say with a slope of less than 5 degrees, and in case the slope is less than 2 degrees, then aspect doesn't matter. That is how, in which direction it is facing, it doesn't matter. So these are all the criteria that we have with us. Maybe there may not be, we are taking this from an example from the exercise manual, training manual, but there may not be any location at all when we take the building data and all those data sets from OSM, main road and restaurant and school data, as well as we will take the DEM and calculate the slope and aspect. We may not get the ultimate result, but the idea is to learn how to do spatial analysis using such criteria, multi-criteria. So let us try to fetch the data. To start with, you launch QGIS application and then create a new project and save it as spatial analysis in the solution folder. And then we have to define a new the aerial extent of your analysis, the Pune metropolitan area. So you can make use of web quick map services to add the OSM standard maps. Then it will add this layer. You zoom to the extent. Now this is the area of Pune, Pimpri Chinchwad, and this is the metropolitan area, and also surrounding regions we are considering, because we don't have any readily available shapefile of the metropolitan area. So we will fetch the data from the OpenStreetMap, all the buildings data, schools, restaurant, roadways, all these data sets we will fetch from OSM using the Quick OSM plugin. So I have already done it for buildings. It is a thick layer. So you can see this is the building data that has been fetched. How it was done is, once you fix the layer of extent, you go to vector OSM, quick OSM, and then in the quick query you need to know the key value pairs, in which format the data is available. Now, like if you go to this, if you search for map features OpenStreetMap, you will go to this wiki.openstreetmap.org, where you will find the variety of data sets that are available, features that are available in the form of key value pairs, and you can search for buildings. Building is a key, and under buildings there are many values like type of buildings, apartments, or commercial, religious, all those things. What I have done is I have only taken the value, the key value, without passing any key as building, and without passing any value, and then I had selected the canvas extent in this option, and under advanced tab, because we are going to fetch polygons data, you can uncheck points, lines, and multi-lines, and then if you want, you can increase this timeout, because we are going to fetch a very dense data of buildings. You can increase the timeout to fetch the data, and then you click on run query. Once you do it, it will take some time, but it will fetch the data. This is the data that it has fetched. Now I will do the same procedure. I will adopt the same procedure for getting the roads data set, for which I can again go to quick OSM. What will be the key value pair? You can see highway. You can check, you can take highway as the key, and you remain the value empty, so that it will fetch all the roads data from the OpenStreetMap, and also the canvas extent. You check the canvas extent, which is fixed up to this extent, and then you can check lines and multi-line strings in case of highways, and then run the query. So again, it will take some time. It is fetching data. As you can see, it is downloading data from overpass. Let it fetch the data. You can also check for other data sets, like schools and restaurants, which are available as point data under the key amenity and value schools, and for restaurants it is available under the key amenity and the value is restaurants. It is taking more than expected time, because on OSM, especially highways and buildings are very dense layers, which is a quite comprehensive layer. Data is available. Yeah, now it has fetched. Now if you can see the highway now, whatever it is being fetched, it is being displayed as a temporary layer. This is scratch temporary scratch layer. You have to save it if you want to make use of it for further analysis. So this is highways um, uh, layer, and let us try to fetch more data quickly. I think other things will not take much time. Go to quick OSM, then select waterway key. You need not type it, it will suggest. Once you start typing, you select the key and value. Here I will select the value as rivers, river, and then again select the canvas extent, and in advanced tab you have to select lines and multi-line strings, and you run the query. So now you have waterways. These are the waterways, major rivers. This is Muta, Mula, Pravara, all those rivers. Then next thing is, reverse is not will not be used in our analysis, but still I had just fetched the data. I can even yeah, I have to get the data of restaurants and schools, for which I will launch quick OSM, and then you can see under amenity you have uh, schools, and then restaurants. Yeah, amenity value is school, and for restaurant the value is restaurant, amenity is the key. So let us do that. You select amenity as the key, and the value you can select it from here, restaurant, canvas extent, and select your points, and then run the query. Similarly, you can do it for school, run the query. Now let us have land use as a key and keep it empty, value keep it empty. It will be multi polygons, so I will unselect points. You fetch the data. You can also fetch places. Yeah, place, so I'll select the key of place and we'll keep this empty. Canvas extent, multi polygons, run the query. So I had generated quite a many layers, temporary layers. You can see all these are listed here. So what I will do is I will save them. Because it is taking more than expected time, I will try to finish it off without going into much details. So you can follow up on the the QGIS exercise manual, the same the steps which were followed there, you can follow it up on your own. You have to do the kind of analysis, buffer analysis, to create buffer around the schools and around the buildings, to see the distance between school and the building, the probable locations of your building, all those things. Then finally you have to select the uh, likely locations where you can which suits the criteria, and then you will import a raster layer. You will use the digital elevation model, then calculate the slope and aspect, and then you will see the conditions of slope and aspect are also whether they are meeting or not, and then you will finally run a query of meeting all these conditions which we have seen in the previous slide, and we will select the residential properties meeting all the criteria. Such a residential property may not be existing in this case because the example is from somewhere else, but still we will follow some steps for your understanding. So first of all, I have to save all these layers. These temporary scratch layers can be saved by clicking on this temporary scratch layer symbol, and then you can give a file name where you want to save. You can create a new folder of exercise data, OSM data, and then you can save by a name of rivers, and nothing else need to be changed. So you can do that for highways, for buildings, and prepare your data. Let me create a folder of OSM data, and then I will save it in this folder under exercise 9, exercise data session 10. So first, waterways. So I will save it as rivers shapefile. OK. Then I can remove this. Then places, land use, the schools, I can save it as schools. You have to specify the geometry type. I think it is not needed because it is understood while fetching the data itself. You have given the options, and here it is a point layer only. So click on OK. Similarly, do it for highways. You can save it as roads, restaurants. You can save it as restaurants. And what else? Yeah, buildings, which is most important. Buildings. It could not make temporary scratch layer permanent. No issue. You can save it as you can activate it. Now try it again. Buildings. Yeah. No. What you can then we can use the normal way of saving it as save features as, and then give the file name. export to vector file failed. Let us try to save it as a in a different format. Export save features as, I will save it as a geo package with the layer name building, with the name training data, geometry type you can mention it as polygon, and then click OK. So it is being saved here. Progress you can see. So a new geo package layer has been saved. In fact, you can add all these layers to the same geo package. As you may be knowing, geo package is a flexible data format where you can store raster as well as vector layer, and also in shape files you can only store point data in one file, polyline feature in one file, and polygon features in another file. We cannot have the combination of these points, lines and polygons in one single file. Whereas in geo package there is no such restriction. You can save many files. It is like a database rather than a strictly vector format. So in this way you can you can save your data training data sets. So once you have saved the scratched layers as shapefiles, whether as S3 shapefiles or as geo package, we have saved the buildings as geo package and remaining as shapefile. Now the first step for doing the vector analysis, because we are going to talk in terms of SI units, the distance from you have to identify the buildings which are within a specified distance from schools, restaurants and roads. So first step is to reproject your layers into UTM projection. Now UTM projection for this area, Pune region, it falls in UTM 43 North zone, and you can always check the projection system of the any EPSG code for any projected CRS by visiting this website spatialreference.org, where you can search for UTM 43 North and you search. So you will find this option. Datum, you have to go by universal datum WGS 84. These are the old datums which are no longer means which we don't want to use. Something which is globally acceptable is UTM WGS 1984, and then the UTM zone 43 North zone, 43 North Hemisphere zone. The EPSG code is 32643. You can note it down. And then now let us start our QGIS. Let me add all the layers that I had saved. I will quickly go through because we cannot spend much time on this. I will and you have the material available in the form of QGIS in the documentation. The same example for a different area is there in training manual of QGIS documentation. So let me add this restaurant, roads, schools and rivers is not required for our problem. Schools, roads, restaurant and buildings, I had saved it as a geo package. When I tried to save it as a shapefile, it was giving me some error. So I will add all these. And how to add any geo package? For that you need to make a connection with the geo package first. So you go to the same option of Open Data Source Manager and go to the Geo Package tab here, and then click on New Connection, and where you have saved your training data, OSM data, you can select it and open, and then click on Connect. So all the layers which are within this geo package, for the time being there is only one layer, buildings layer is there, but you can store all these schools, roads, restaurant layers also in the same geo package. So then you can after making the connection, you can add the layer onto your canvas area. So all the layers have been added. Now we will project each of these layers which are in EPSG. You can check the CRS of each by clicking the layer properties. So each of them I think is in EPSG 4326, that is global coordinate system. This is unprojected coordinate system, but we cannot work with degrees because we have to deal with distances in metric units. So we have to project all these layers into the UTM 43 zone, the projected coordinate system. So you can export each of these features as save feature as, and then you can save it to the same geo package of buildings training data. You can select the geo package, and here instead of CRS 4326 you can select 32643. You can search for you click this globe symbol here, select CRS, and in the dialog box in the filter you type 32643, and then it will show you the results in the recently used coordinate reference systems or in the predefined coordinate reference system. You can select it and then press OK, and then keep the other aspects as it is. Geometry automatic, but still you can give it is a point data, schools data, so you can select point and then click OK. Then as you can see, a new layer has been created, training data schools. You can check its CRS from the layer properties. Now it will be in EPSG 32643 WGS 84 UTM zone. This is Universal Transverse Mercator projection. Same thing you can repeat for roads, restaurants, and buildings, which are all in global coordinate global coordinate system. And once you do that, the second step will be creating buffers. Like you have to identify the areas which are within the buffer of 1 kilometers from the schools. Then you have to identify the areas because in our problem it is stated that you have to identify the buildings of area greater than 100 square meters, but which are within a zone of 1 kilometer of the school and 50 meters from a road, any kind of road, and 500 meters from restaurant. So you can create all these buffers. Now how to create any buffer? For example, for school which is in 32643, this is my uh, projected school point layer. I can create buffers by going to the option processing toolbox. You can search for buffer tool, which you will find in vector geometry. Under vector geometry you will find this option of buffer. You can click it and then it will open a dialog. You can read what the algorithm does. So we will give the input layer as training data schools, which is in EPSG 32643, and the distance you can specify it as in meters, that is 1000 meters, which is 1 kilometer, and then you keep the remaining options as they are default options. You can even save this as a buffer layer by giving by saving it to file. You can name it appropriately, like schools underscore 1 kilometer buffer, something like that. Otherwise it will create only a temporary layer. So you see, for every school, I will keep the school on the top of this buffered layer. It has created a buffer area of 1 kilometer. So for points, it will create a circular area. Similarly, you do it for 50 meters for roads, 500 meters for restaurant, and then you once you have all these areas, you can have the overlapping area of all these areas from intersect tool, which is again available in this processing toolbox. You search for intersect, which will be there in under vector overlay. Yeah, intersection. Here you will give the input layer as schools buffer, and then buffered, and then the overlay, you will overlay your buildings and see which all buildings are within 1 kilometer of the school area, that you can run. But the buildings, my layer is still in 4326. You have to reproject it first and then do this analysis. So if you keep doing this, applying these filters, you will ultimately, you will get a subset of the original buildings which are uh, meeting the criteria of the distance criteria of 1 kilometer from school, 50 meters from road, and 500 meters from restaurant. And then you can see the area of buildings. Now, first of all, let me export my buildings layer as a geo package. I will add it to the same, but I have to name it differently. Buildings underscore say 43N, that is UTM zone. You take EPSG 32643, and these are polygons, and then you reproject it. And once it is done, we will see how to calculate the buildings which are meeting the criteria, and also the meeting the criteria of area greater than 100 square meters. Then you will finalize the set of buildings which are meeting the criteria, and then you have to do the raster analysis. By we have to select those buildings meeting all these criteria, and which are located in an area where slope is should not be greater than 5 degrees, and aspect also we have to see, it should be south facing if the slope is uh, less than 5 and greater than 2 degrees. If it is less than 2 degrees, you can neglect the aspect also, that it has been the criteria given in the problem. So you can see this is the building data set. Now if you want to calculate the area, you open its attribute table. Now for the time being, we are working on the whole building set. We haven't yet filtered out the buildings which are intersecting with the buffer areas. I just wanted to show you the procedure. So if you open this attribute table, there are many features here. So it will take a lot of time if you run it. So here you will have this option of select features using an expression. So here you can select fields and values, and then you can create a new field. You can go to edit option, toggle editing. You can add a new field. You can define it as area, the name of the field as area, and then it will be in decimal. Okay, and then once you filter out the buildings, it will not take so much of time. If you go to the column of area, you can go to field calculator option. You select the update existing field which you had created, that is area, which will be at the end. And what would you like to update it with the area, which you will find the option under geometry, dollar symbol area. You double click it. So if you run this expression, which will take some time for running for the entire number of features, it will calculate the area for each feature and it will populate for all the features. And then you have to filter those features of the building which are within the buffer zones and whose area is greater than 100 square meters. So you can see, uh, you can sort the area, or you can select the features which are first of all you have to save the feature. After you do this, then you have to select the features which are having area greater than 100 square meters. We have seen how to make use of the attributes and select the features by expression and by other means in the beginning of this session. So in this way you do the vector analysis to identify the areas which fit the criteria to answer the problem at hand. Now, after conducting the vector analysis and identifying the buildings which are suiting your criteria, that is whose area is greater than 100 square meters and whose distance from the schools, the restaurants and roadways is less than the given stated conditions in the criteria. Now you will have to check whether the other conditions on related to slope and aspect are also fulfilling. For that you have to conduct the raster terrain analysis using the DEM tile. You will basically you will see those filtered buildings or residential properties and see whether they are located in those regions where the slope is less than 5 degrees and aspect is south facing, or if the slope is less than 2 degree, the aspect need not be considered. That is the problem statement. So let us first load our DEM tile. We had downloaded the DEM tile and used it in the previous session from CGIAR CSI Geo portal. I will add the same tile, and to check whether it fits, it is occupying or it is extending up to your area of interest, you can add a base map from web quick map services and then select OSM standard. Now you will see, you can check whether it covers the Pune metropolitan region. It is covering, so you can make use of this DEM tile for further raster terrain analysis. This DEM tile is in EPSG 4326 projection. CRS is global coordinate system. You can get to know about it by quickly hovering your mouse over the layer, or by double clicking and going to the properties. Under information you will find it, layer properties, you will find this. So we have to project it to the UTM coordinate, UTM projected UTM zone 43 north. For that you have this option under raster menu, you have the option of projections and warp project. You click on warp reproject and you click the input area is your SRTM original tile with in the global coordinate system. The source CRS, you can check here, it will be already be there, which is same as the project CRS, but still if you go and click this symbol of select CRS, and then if you select the option of predefined CRS, you can search by the code 4326, which is the source CRS. It is the global coordinate system. So you can check this and go back and then target CRS, the projected coordinate system which you intend to reproject this layer to, which is UTM-43N, that we have seen it. The EPSG code is 32643. You can click again on this select CRS and then go to the predefined CRS and then search for 32643 and select under the projected coordinate system. Go back and you keep the resampling method as it is, the nearest neighbor, and you can save the reprojected layer or keep it as an intermediate layer, temporary layer. Ultimately you want to calculate the slope and aspect, so you run it. So you have this reprojected layer. You can hover the mouse or check its layer properties to see the CRS, which is 32643, which is the projected coordinate universal transverse Mercator system. Now we will calculate the slope by using processing toolbox. The options under processing toolbox, you search for slope, which you will find under raster terrain analysis group of tools. You have to provide your input elevation layer, which is reprojected layer, which is a temporary layer in EPSG 32643, and you keep the other options. You can save it to your disk as slope, or you can run it, which will create a temporary layer. We can save it afterwards. You can run this, so you can check that slope layer has been created. Most of the areas are you can check the identify feature button and check the values. Most of the region is gently sloped. However, near the divide, western divide, where this Western Ghats ridge line, the slope is as high as 50 degrees. So this is one thing, and then we will calculate the aspect. For that you will again go to processing, check the toolbox, and then aspect. You click on aspect tool under raster terrain analysis. Again you give the elevation layer as reprojected and then run this, which will calculate the aspect, whose value will vary from 0 to 360 degrees depending upon the face, the direction in which it is facing. So you can see the values, check the values in degrees, which vary from 0 to 360. Now in the problem statement, you have to identify the areas which are facing south. So for that you can make use of aspect as the input layer to calculate to filter the areas which are facing south, where aspect is greater than or equal to 90 or less than or equal to 270 are the pixels, where the aspect ranges between 90 to 270 face the southern direction. So we can implement it using raster calculator. You can go to processing, toolbox, and then search for raster calculator as we had used it earlier. You will find it under raster analysis. You click on raster calculator and then you write the expression by double clicking on aspect. So aspect should be greater than or equal to 90 and it should be less than or equal to 270, which will fit our criteria. So this expression, if it is valid, then you will find this green expression in green color expression is valid, and then you can run this. Before running, you can give a reference layer for automated extend cell size and CRS. You can select the aspect layer itself, and then you run this, which will create a Boolean layer wherever the expression is valid and aspect is between 90 to 270. It will give a value of 1, otherwise the value will be 0. No data values will be treated as no data. I think no data values are there where there are water bodies. Like if you see in the aspect, here you have no data value in the sea, and also inland water bodies you will find, because they are flat. Anyway, we will see that. So in the output, you see the output varies from 0 to 1. Either it is 1 or 0. Now we are interested in considering the values of pixels where the value is 1. Now to check whether you can, with identify features, you can check only the values of an active layer one at a time, right? You can either check the output, or you can either check the aspect. If you want to check the values of all the raster layers which are there, you can make use of one plugin, useful plugin. You can download it by searching for value tool. Okay. I had already had a look at it. Value tool, which is a QGIS plugin to display in table or plot values from raster layers at the current mouse position. You can install this plugin. Once you install this plugin, you will find a panel of value tool getting visible here, and then you can select a few output and aspect rasters active, keep them active, and then you can scroll your mouse anywhere where you will find the values of output and aspect changing as you scroll the mouse, and wherever the value is less than 90, as the output should be 0, and if it is greater than 90, it will be, and less than 270, it should be 1. So I think our Boolean layer is fine. So you can cross this value tool, and similarly you can create a Boolean layer using slope by raster calculator. You can generate one layer, one Boolean layer where slope is less than or equal to 5 degrees. It should point out to 1, and where it is greater than 5, it should be 0. Similarly, you can calculate where the slope is less than or equal to 2, it should be 1, and when it is greater than 2 degrees, it should be 0. Now you put all these three conditions where this aspect is 1, the southern facing, and where slope less than or equal to 5 degrees is 1, or wherever slope is less than or equal to 2 degrees, then you need not consider the aspect. You again implement a expression in the raster calculator by writing an expression, and then you will get finally areas or the pixels where the slope is less than or equal to 2, or where the slope is between 2 to 5 and it is southern facing. You will find those the pixel values in the form of raster. Now to combine the analysis, the raster analysis as well as the vector analysis, you have to convert your raster layer into the final raster suitable suitability raster. You can name it as suitability area raster layer, and you can convert it into a vector wherever the values of 1 are there in the raster, they will be in the vector, it will be a suitable value polygons will be created. If it is contiguous area, a bigger polygon will be created. In fact, you can do the sieve analysis also, but I am skipping all those things because we are short on time. So once you have the suitable pixels from raster analysis, you can convert it into a vector by the option of raster conversion polygonize from raster to vector, and then you fit the buildings which are intersecting this newly created uh, polygonized raster to find the final set of buildings or residential properties which suit both the criteria in all the criteria. In this way, you can do the spatial analysis to identify regions which fit multi criteria, which can be easily done in using any GIS application, making use of raster calculator and making use of expression in vector analysis. There are many tools like buffer. So that is for this session on basic spatial analysis. In the next session tomorrow, we will be covering hydro processing of dam and catchment delineation. I will suggest you go to QGIS documentation. We had covered sufficient content for teach for the basics for working with vector data and for working with raster data as well as doing the analysis. And we have also covered many plugins which will be very useful. Quick Map Services plugin, uh, this value tool which we had just used, that is also very useful when we want to check the values for multiple layers. So we will meet tomorrow then. Thank you very much.